The purpose of this warm-up is to have you practice answering the reflection questions for your project with a sample set of data. So the first reflection question you're going to be asked on your project is whether the distribution is symmetric, skewed left, or skewed right. So from this distribution, just visually it looks pretty symmetric, meaning if I drew a line of symmetry, or I drew a line down the middle of the histogram, the left side reflection of the right side, or the two sides. I'm going to start off with that. Okay, and the other thing I'm going to be looking for here is a comparison of the mean and the median. So let's look at our mean and our median. Okay, so the median is 5, the mean is 4.875. Okay, so because the mean and the median are within one number of each other, they're pretty close to each other. That's another way that we're going to be able to prove that this data is approximately symmetric. Okay, so the mean is approximately equal to the median. All right, next question. Is the mean or median a better representation of the data? Explain in detail the meaning of your choices. The key thing to know is that median is a better measurement for skewed. So right, that would be a sign that you would want to use the median. So because we decided that our data is symmetric, it actually doesn't really matter if we use the mean and the median, because in this case, because the data is symmetric, mean or median works as a representations of the data. Okay, just for grammar's sake, I'm going to fix this a little bit. Let's say mean or median both work as representations of the data. And the key thing here is that if the data is skewed, that's when you would want to use the median as your representation. If it's symmetric, mean or median does not matter because they're approximately equal, so it doesn't even matter which one you choose. All right, describe the meaning of the standard deviation in words. Okay, so standard deviation, this was a day when a lot of us were absent due to AP exams, so I'm glad we're reviewing this before your project. So the standard deviation for my data is 2.075. Okay, So what that means is that on my data points fall 2.07 away from the mean. So the standard deviation is a measure of how spread out your data points are, how far away from the mean they are. So say this is a measure of how variable or how spread out my data is. Okay, one quick thing I wanted to mention is that in the context of my survey question, which is on a scale of 1 to 10, how much do you enjoy school? So this was a survey I gave to my students last year, like as an example, and these were their responses. Because the data is approximately symmetric, what that tells me about people's enjoyment of school is that most people fell between like a 4.4 and a 6 in their rating of school. So I'd say most people are kind of neutral about school. It looks like there's a few people who are like, oh, I really love school, like I'm up here at a 9, and a few people were like, I really don't like school, they were down here at a 1, but most people were kind of like neutral in the middle, like school's alright. And the standard deviation would be like how spread apart those responses are, how far away from each other. Okay, last one, this is the most recent thing we learned. The data set is as follows. Here's the list of responses that I got from students, and are there any outliers? Fully justify your response. Okay, so let's remember quickly the definition of an outlier. It's any numbers 1 minus 1.5 times the IQR. And the second data point or plus 1 point. Sides of this, that's not given to me. So the I number Q3, my Q3 is 6 and my Q1 is 4. So I'm going to do 6 minus 4, which is 2. So my IQR is equal to 2, and I'm just going to plug into these two equations for outlier. So my Q1 value, a little annoying, you have to keep flipping back and forth. My Q1 is 4. So do 4 minus 1.5 times my IQR, which is 2. 1.5 times 2 is 3. And 4 minus 3 is 1. So my outlier would be any number less than 1. And you can see in my data set I don't have any numbers less than 1. If I had a 0, then it would be an outlier, but I don't have any outliers on this side, on the left side of the distribution. Let's check the right side of the distribution. Any number greater than 6 plus 1.5 times 2. 6 plus 3. Any number greater than 9. And it looks like the highest number in the distribution is 9. If I had a 10, that would be an outlier, but no one said 10. So I have like these two possible outliers, and neither of them are present in the data set. So let's justify our response. Are no outliers, no values are less than 1.5 times the IQR, less than Q1, or greater than 1.5 times the IQR, greater than Q3. Another way of phrasing that would be there are no values less than 1. and no values 9, which were like my 2 parameters that I calculated. All right, so what you're going to do now is practice this with the next question. So the next example question is, I asked students, what is your CSU weighted GPA? What you'll need to do, key part of this instruction, is you'll actually need to open up on Google Classroom. There's a document called Project Practice. It's like a Google Sheet. And you're going to go through and practice using the shortcuts to use your spreadsheet to calculate all of these statistics, and then you're going to go ahead and create a histogram and then answer these same reflection questions. You also have the option to answer these reflection questions. You can just type your answers directly on the Google Sheet if your hand hurts and you don't want to write anymore. Okay, get started on the practice and ask questions if you need help. Good luck.